Hello, year three. I hope that all of you are healthy and safe. In our today's session, we will start a new topic, which is forces and motion. The study note number 2 is just covering the learner book from page 116 to 125, which is only the first part of the topic. Let's start. Please concentrate, and I hope that you enjoyed the session. What is a force? What's meant by a force? Objects around us don't move by themselves. They need a physical force to make them move. So a force is something that we cannot see. It's invisible, but we can see the effect of a force on an object. So if we need to move an object, we need a physical force to make them move. And force is something that we cannot see. We can't see a force when we are applying it, but we can see the effect of the force. What are the effects of the force? We are going to know it by the second part. Force is usually represented either a push or a pull. So any force we are applying is either a push or a pull. For a push or a pull to happen, there must be two objects. Have a look in this picture. You're going to find a man and a door. So we have two objects to perform our force or to apply our force. So the force to happen, there must be two objects. In other words, most forces need contact between objects. Objects must touch each other to apply a force. Pushes and pulls. What are pushes and pulls? What's the difference between pushing and pulling? Let's know. A push is when you use the physical force to move something away from you. Have a look in the picture. This boy is pushing the box away from him. So a push is when you use a physical force to move something or an object away from you. While a pull is when you use a physical force to move or bring something towards you. Have a look on the boy. The second boy is pulling the box. So to push is to move something away from you, and to pull is to bring something towards you. Look at the pictures below and think what force is being used to move the object. What do you think about this woman? She's playing with her son on a seesaw. What she's going to do to perform a force to move her son. She's going to push the ground to move the seesaw. So the woman is pushing the ground to move the seesaw. What about this little girl? What she's going to do to move her brother? What do you think? Is she going to push or pull the swing? To move her brother away from her, she's going to push the swing to move it. So the girl is pushing the swing to move it. Have a look in this picture. This is hiking or hiking. Both are right, don't worry. What do you think? What the woman is going to use, which force, this woman is going to use which force to move? By the way, she's going to use both types of force. The woman is going to push the hill or the mountain, and so she's going to pull the rope to go higher. So this woman to move use both forces. She pushed the hill and pulled the rock. Weight, mass, and force. What's meant by a weight? A weight of an object is the force pulling down on it. The weight of an object is the force pulling down on it. So please importantly note that weight is a force. Weight is a force that pulls the object down. The heavier the object, the more force pulling it down. If I have a heavy object, it's going to have more force pulling it down, and this will make it difficult to move. Imagine that you are lifting a chair and lifting a pencil. What do you think? While you're lifting a chair, you will need more pulling force to move than lifting a pencil. If you want to pick up a pencil, you will not exert or apply a very hard pulling force. No. But when you are trying to lift a chair, you are going to apply more pulling force to move it. We measure forces in Newton, which is also written as a capital N. It's very important. Please note that we measure forces, any type of force. We are going to measure in Newton. Newton is the measurement unit or the measuring unit, and it's written as a capital N. So what about mass? Mass is different other than weight. We said weight is a force, but mass is the amount of a material in an object. You have a mass. What is the material in you? You have bones, you have skin, you have muscles, you have liquids, you have blood, you have organs. All of those materials together considered as your mass. If you have a pencil case, what is mass? Its mass is the amount of pencils and pens and sharpeners and rubbers, rulers, whatever you place inside it. It's many materials. So the amount of these materials considered the mass. So mass is the amount of material in an object, and it is not force. Please take care. Mass is not a force. Mass is usually measured in kilograms or grams. Grams and kilograms are the measuring units of the mass. So back to the forces. What about measuring forces? We said that the measuring unit of forces is Newton, which is represented as capital N. What's the device we are going to use to measure a force? We are going to use a force meter to measure forces. If we need to measure a weight, which is a force, we are going to use a force meter. Those are many types of force meters. Every one has its purpose. Did you remember? Don't you remember that every material is made for a certain purpose or a certain job? Yes. Different colored force meters are used in different purposes. What's a force meter? Let's know together what's a force meter. What are the components of force meter? How it's going to measure the force, how it's going to measure the weight. All force meters have something called the spring. The spring stretches when you hang an object on the hook. Did you see the hook in the picture? Yes, at the bottom of the picture, the circled one, this is the hook. The spring stretches when you hang an object on the hook, and this is because the object is applying a force. Because as we said before, that every object has its own force, which is pulling it down. So when you hang an object on the hook of the force meter, the spring is going to stretch. The plastic ring I show you in the picture with the blue circle, there is a plastic ring which moves up and down with the spring. This plastic ring moves to show the measurement of the force in Newton. The plastic cylinder is graduated in newtons. While the spring is stretched, this plastic ring is going to move down, and it will show the measurement of the force in newtons. The force meter that the scientist chooses is to use depend on the mass of the object it can hold. It's very important. That's why we have in the previous slide many types of force meters, because the force meter that scientists decide to use, it depends on the mass of the object it can hold. Mass is the amount of material in an object. I can't use a force meter which stands to hold only 5 grams and place in its hook an object of 50 kilograms. It will not work. So every force meter should be chosen depending on the mass of the object it can hold, how much mass it can hold in his hook. Do you know that when you hang an object on a force meter, gravity pulls it down? Do you know what's the gravity? Gravity is the pulling force that keeps us on our planet. Why we didn't fly in our planet? Why we stay stable on the ground of our Earth? Due to gravity. Because gravity is a pulling force, which is usually pull us down to keep us on the ground. So do you know why newtons are called like this? Newtons are named after Sir Isaac Newton, the scientist who discovered the gravity. Isaac Newton is the scientist who discovered the gravity. The pulling force is the one who discovered that the Earth has its gravity. That's why the measuring unit of any force is called after Sir Isaac Newton. So when we need to measure a force, we use newtons as the measuring unit, referring to Sir Isaac Newton. Starting objects to move, or starting objects moving. When an object moves or changes direction, forces are working. Think about your football. When you're playing football and kick your ball, did the ball go in a straight line? Or if you push with a harder force, it may change its direction? Yes. So when objects move or change direction, forces are working. And as we said before, most forces are invisible. We cannot see them. So when we want to represent them on papers or during studying, we show them using arrows. These arrows can show the direction and the size of the force, if it's a large force or a small force. If this force is going to the right or going to the left or going to backwards or going to forwards, the arrows is going to show all this information about the force. Have a look in this picture. This arrow is large in size. It represents a large force. While when I want to represent a small force, I drew a smaller arrow. So large arrow represents large force, while a small arrow represents small force. What about the black arrows? The black arrows show the direction of the force. So one more time, the above blue arrows show the size of the force. If it's large, it's going to be represented with a large arrow. If it's a small force, it's going to be represented with a small arrow. Concerning its direction, it doesn't matter the size. The direction of the arrow is the most important thing. If you draw like this, it's going forward. And if you draw like this, it's moving backward. And these arrows are assigned according to the moving object. How you are going to move your object. Will you move it forward or you're going to pull it backward? So the direction and size of the force depend on the applied force. Small push or a big push? Is there a difference? Yes. If you push a marble with your fingers, once with a small push and the other with a bigger push, what you will find out? Did you play marbles before? I think, of course, yes. Try to imagine that you have some marbles with your finger and you push them once with a small push or a little push and the other with the bigger push or a harder push. What you're going to find out? You're going to find out that the bigger the push, the bigger the force, the longer the distance the marble travels. If you push the marble very hard with a big force, it's going to move for a long distance. But if you apply a small push, the smaller the push, the smaller the force. And then the shorter the distance the marble will travel. If you push softly on the marble, you will give it only small force, which will make it move only short distance. So now we clarify that the bigger the push, the bigger the force, the longer the distance a marble travels. While the smaller the push, the smaller the force, and the shorter the distance the marble travels. By this slide, our today's session has finished. Please write down all your questions in a piece of paper so we can discuss them next Thursday during the online session. Your today's homework will be in your workbook, pages 68, 69, 71, and 72. By the end of the week, a model answer will be sent to you so you can check your answers easily. Thank you so much, my beloved students, for your concentration. See you next session. Goodbye.